Hello guys, this is Ukeze Chedozie from Special Maths Academy. In this video, we're going to be solving question 43 from 2021 Senior Maths Olympiad first round. The question goes like this. In a tennis tournament, n women and 3n men play, and each player plays exactly one match with every other player. If there are no ties and the ratio of matches won by women to the number won by men is 3/4, and the number of players do not exceed 26 in all, find n. What we're going to do now is that we'll be making use of all the information we've already been given in the question, and we'll see what we can get from that. So we're told that there are n women in the competition, and also we have 3n men playing. This means that in total there are 4n participants in the competition. Yes. So the total number of games they're going to play will be 4 in combination 2. The reason for this is that we're told that each player plays exactly one match with every other player. So every pair of participants are going to play a match with each other. So that's why we have 4 in combination 2 games in total. So this is it. So we're going to go ahead to expand 4 in combination 2. That's going to be 4n factorial over 2 factorial times 4n minus 2 factorial. So this is going to be 4n times 4n minus 1 times 4n minus 2 factorial over 2 times 4n minus 2 factorial. And this is going to be 2n into 4n minus 1. So this is the total number of games that are going to be played in the tournament. Then let's see the other things we have. We're told that there are no ties and the number of matches won, the ratio of matches won by women to the number won by men is 3/4. So let's say that there were 3x games won by women and the number of games won by men is going to be 4/3 times 3x, which is 4x, since the ratio is 3/4. Since a game will either be won by a woman or a man, the total number of games played is going to be the number of games won by a woman plus the number of games won by a man. So there are going to be 7x games played. So this is the second piece of information we have now. So what's going to link it together is the fact that 7x is going to be equal to 2n into 4n minus 1, since both of them represent the number of games played. So 7x is equal to 2n into 4n minus 1. Then when we look at this equality we have here, the left hand side is a multiple of 7, which means that the right hand side too will be a multiple of 7. So since 7 is a prime number, that implies that 7 has to divide 2, or 7 has to divide n, or 7 has to divide 4n minus 1. But this first case is actually not possible since 7 doesn't divide 2, we'll have that. This means that 7 has to divide n, or 7 has to divide 4n minus 1. So these are the two possibilities that we have. So we'll just scroll down a bit. So if 7 divides n, the possible values of n are going to be 7, 14, 21, 28, and so on. And for the second case, that's when 7 divides n. If 7 divides n, that means that n has to be one of these. And if 7 divides 4n minus 1, the possible values of n are going to be 2, 9, 16, 23. You can easily get those values out. So these are the possible values that n can take: 7, 14, 21, 28, and so on. Just keep on adding 7. And this other one, 2, 9, 16, 23, and so on. And just keep on adding 7 to all those numbers to get the rest of them. So we're going to make use of the last thing we're told now. So if we go back to the question, we'll see that they said the number of players did not exceed 26, right? So that means that 4n, since there were 4n participants, 4n is less than or equal to 26, which means that n is going to be less than 26 over 4, which is going to be 6.5. And the only value of n here that is less than 6.5 is 2. Since these are all the possible values of n, so this means that n has to be 2. So n equals 2 is the answer to the question, which is option A.